All right, so Monday, October the 16th. Let's see, I did want to hit on a safety topic. Anything interesting happen at work?
Not today.
No. Any safety issues at work? Where are you working at?
Fair play.
Fair play?
Yeah, water treatment plant.
Are you? Okay. All right. What I really want to go over as far as safety is just job environment. So, you know, think about it. In a water treatment place, job environment, rigid conduit, aluminum. Any confined spaces?
Not to my knowledge of right now.
Okay. Work on a ladder or scissor lift?
We're still on the underground.
Underground?
Mm-hmm.
So, just underground work. So I think the biggest thing to be aware of, any equipment you've just been running around you, like trenchers and stuff like that.
They got some mini-X out there.
Mini-X. So, biggest thing, being aware of your environment around you, and understanding that mini-X can hurt you if you get in the way, right?
Mm-hmm.
So, any precautions you take?
I guess make sure he sees us.
Yeah. Would you wear your PPE, right?
Yes, sir.
PPE there is required as what?
Hard hat, glasses, gloves,
Vest
vest.
or some type of safety? You got, I guess that's shirt,
Yes, sir.
safety boots, if you're outside. Okay. All right. Okay. All right, page 28, where we're gonna start. Commercial occupancy calculation. So, we've been doing calculations, so really our emphasis would be, I do want to do this, go over, I tell you what, before we start that, the review questions, we're just going to go over those with me.
Yes, sir.
Review questions at the end, there's 3 at the end of section number 2. So it's just 3 questions, so let's go over those, page 27. Because we did the fill in the blanks last week, didn't we? Didn't we, for section 2? Yeah, we did. Yeah, I know we did. Yeah, you got those, right?
Mm-hmm.
Section 2. All right, so let's go over those 3 questions on page 27. So number 1 says the backyard pool pump house is not listed in NEC 220.12. The NEC section that applies to the load calculation for this facility is what?
Is it D?
It's actually C. Let's look it up. Let's look at C. I think it's C. Let's look at 220.14A. Other specific appliances, an outlet for a specific appliance other not covered in 220.14 shall be calculated based on the ampere rating of the appliance or load served. So that's what it tells us it would be. I'm not sure I agree with that. Let's take a look. Let me go to 1.1.1 and see what it says. You said D?
Yes, sir.
220.16, what does that say? 16A, no, I don't think it's that one. Backyard pool pump, let's turn to 1.1.0, see what we can see here. Oh, I'm sorry. 2.1.1. Yeah, that is right. The answer is actually C. Yeah, I did have the answer right. What'd I say, 2.1?
2.1.1.
Yeah, let's look there. A rural pump house sample calculation, so that makes sense. Matter of fact, if you see there, it says, matter of fact, you look at step 1. It says NEC 212 does not list a small pump house, therefore NEC section 220.14A for the calculation. See that there?
Yes, sir.
Okay, all right. Next question. Which of the following considered an occupancy area must be included in residential load calculations?
Is that an unfinished basement?
Unfinished basement. And we would find that at 2.2.0. And the other question, answers are garage, open porch, and carport. We would never consider any of those ever part of the space. Okay. All right, so next one's gonna take a little bit of calculation. And we'll work through it to 2.3.1. Let's look at it together and see what we can come up with. So an apartment building has a total general lighting and small appliance load of 170,000. The net load after the application of demand factors is what? How would you do it? Let me get the pen. Let's go back to 2.3.1 is what we're gonna go back to. Work it out and see what you come up with. See what you can come up with. Hang on while you're working on it. All right, we look at 2.3, let's kind of look at it together. So we got a total load, is what we want to do. All right, so if we look at step 2, under 2.3.1, we got a demand factor. And let's go back and look and see what our demand, what our total was. 177 VA?
Yes.
Is that what it was? All right, so what are we going, 177?
170.
Hmm?
170?
Yeah, 170. So we're gonna take 170, we're gonna take what percent, or how much of that 170 is gonna be 100%?
170.
No, how much of it's gonna be 100%? Look at,
120.
no, look at step number 2,
First 3,000.
3,000. Okay, so we're gonna pull that off to the side. Okay? You want to come over one spot so maybe you can see a little better? And now it tells us in step 2, the next 117,000 is 35%. So we're gonna take 117,000 times 0.35. Let's see what that comes to. Do that on your calculator and see what that comes to. All right, so when you start, your total VA, you take the first 3,000, so we're gonna kind of put it off to the side. And now what we're really taking is, the total was 120, and we're taking what's left. That's why I said 117.
Okay.
You had 120, so you're taking 3 out of it. That's what you did there. Gives you 117. That's how I come up with that number. Okay? So 117,000 times 35% is what?
$42,000.
42,000. Now we're going to put that over to the side. Now how much do we have left? We started with what, 170?
Yes.
Where we're taking out 3, and we're taking out 117, right? To get what's left. You agree? So how much is left? Take out that and see how much is left.
50?
Is it 50?
Yes, sir.
All right. Now, how much percentage are we gonna take of this 50,000?
It'll be 25%.
25%. Okay? All right. Give me how much that is.
12,500.
All right, let's see how much we got. 57.5? Is that one of the answers? Or did we do something wrong? We did something a little bit wrong. You sure? Let's do our calculations. All right, let's take 117,000 times 0.35. 40,950 is what I got.
Oh, I know what I did wrong. I put 120.
That's where a lot of people make a mistake. So 40,950. This one doesn't work. So then we're going to change this number. Let's see what we'll come up with now. 40,950. That gives us 5, 14, 5, 6, 56,450. Is that one of our answers?
You said 57,450?
Yeah.
Yes, sir.
Yeah. But you see how we got that? The biggest thing is, I say, is making sure that you take the 3,000 out of the 120 to get to 117. The second step, the first step is just taking out 100%, first 3,000. The second step is taking out 35% up to 120,000, but you've already done 3. So you got to always take this out
Okay.
to get to 117. And then all you're doing is what you got left. So really you're taking 170 minus 120, aren't you?
Mm-hmm.
And that's what you come up with, 50 to get to that. See how we did that now? That takes care of that. That's our 3 review questions. All right, so on page 28. We're dealing with different commercial aspects. You can kind of see there, 3.00, what we're going to be looking at is retail shops. Well, first of all, let me ask you, ever worked on a retail shop?
No.
Okay. How about an office building?
No.
How about a restaurant? Okay. How about a hotel? Motel?
Apartments.
School?
No, I haven't
No.
worked in school.
And the last thing we'll be looking at will be marinas, boatyards, farms. So that's kind of what we're looking at. So we're going to kind of go through some of these. So on page 28, if we look there, commercial, the trade term that you're actually looking for tonight is separately derived system. Probably the most common separately derived system that you work on your job is what? Any idea? Look at the definition. Let's look at the definition now to determine maybe something that's on your job that meets this criteria. It says an electrical source other than a service, so it's not your income and service, having no direct connection to circuit conductors of any other electrical source other than those established by grounding and bonding connections. What would be on a job that you may work on a lot that could be described as that? Any idea? How about a transformer? Think about that definition. Would that not meet the criteria? What happens inside of a transformer? We're creating what? A different voltage, aren't we? Which is in essence a separately, we're creating circuits within that transformer. And so separately derived system, a good example of that Let's read it again. Now think about a transformer. So it says an electrical source, isn't that not a transformer? Electrical source, isn't it power come out of it?
Yes, sir.
Other than service, is not a service, right? For service is what comes into the building. Having no direct connection to certain conductors, we don't have any of those, other than the source that's been established by the grounding and bonding. So that kind of meets the criteria of a transformer. Okay. All right, so just looking at the first page here on page 28, it just goes into calculating load requirements. We see here the basic approach to separate loads into categories here. One is lighting. And if you look in your code book, turn to table 220.12. See the table? 220.12?
The table?
Yeah.
Yeah.
See, look, it shows us, as far as lighting, it gives us different volt amps based on different type of structures. In fact, the ones we were just talking about, if you look down, you see that a hotel and a motel is how many VA per square foot?
2.
Yeah. An office building,
3.5.
3.5. A restaurant,
2.
a school,
3.
a store.
3.
And so that's the first thing we're going to be looking at is lighting loads. That's where we get that, all right? The other thing we'll be looking at is receptacle outlets. Well, we learned last week that one thing we know for sure that under 220.14I, if nothing else, we know that a general receptacle is how many volt amps? You remember?
3.
No. How many volt amps? How many watts? 108. That's 220.14I in your code book. 180 volt amps. So you might want to mark that. Okay. The other thing we learned is that show windows are a linear feet. In other words, they're 200 volt amps per linear foot for a show. Are you going to have that in a retail store, a show window?
Yes, sir.
And so a show window, we had a 40-foot wall, a 40-foot storefront, and it says, so we had a 40-foot storefront, and we see, it says 1 volt amp per, or 200 volt amps per foot, doesn't it? So we're going to multiply that 40 times 200, and we're going to get what, 8,000?
800.
That's it.
Yes, 8,000.
8,000 volt amps, so we'd have 8,000 volt amps just for showing the lighting in a store. The other thing in the store would be what? You're going to have something, what you going to have on the front of the store?
Lights.
No, you don't have a light, what you going to have? A sign. And sign right there is 220.14F. And you see that a sign is 1,200 volt amps per sign. That's just kind of talking about receptacles and things like that. Motors, when might you have a motor like in a store or in a restaurant, or how about motors in a restaurant? What might you have, motors?
Conveyor belt.
Hmm.
Or trays.
What's that?
Conveyor belt.
Could be, yeah. What else? Motor and HVAC unit, right?
Yeah.
There could be, how about like a dishwasher could have a motor? How about a disposal? It's motor, right? We got different applications for motors. Okay, that's one thing that we can looking at. And then just appliances. What is like an appliance? Like a microwave? That'd be an appliance. How about a coffee maker?
Yes.
How about a can opener? You know, all those little things. How about a Keurig coffee maker thing? One thing. Okay. So anything like that would be called an appliance. And we know from last week that, like in a dwelling, you have 2 small appliance loads, and how much are they each? You remember?
Yes, sir.
1,500 volt amps per small appliance. And in a dwelling, you have a minimum of 2. Okay, all right. That's some of the things we're going to be looking at. So kind of reading on down there, on page 28, we see that it talks about commercial occupancy should be considered continuous and I'd probably underline that, unless specific information is given. So in a commercial facility, they're saying it should be, and I'm gonna underline that myself, it should be considered continuous unless contrary. So in continuous now, if a load is continuous, what is the one thing we know that we have to do to a continuous load? We have to multiply it times how much percent?
3.
No. 125%. Continuous loads. Always remember, continuous is 125%. Okay. So if we had a 20 amp continuous load, it would be what? 20 times 1.25, right? Okay. Or you could take 20 times 0.25 and then add that to the 20, whichever one you want to do. Make sense?
Yes, sir.
Okay. Reading on. Smaller commercial establishments normally use single phase, 3-wire. Larger projects, 3-phase. Many installations have secondary feeders for panel boards. Separate calculations for feeder and branch circuits. The rating of the main service is based on I probably underline that. The rating of the main service is based on the total load with the load value of the transformer according to the various circuit voltages if necessary. Okay. Demand factors, they apply for commercial establishments. For example, the lighting loads in hospitals, hotels, motels, warehouses are subject to application of demand factors. Okay, we just looked at some of those there. Okay. Just keep it just a second. Let's see who this is. Hello? Hello? Important. Later to it. Okay. All right, picking back up, special occupancy such as mobile homes, recreational vehicles require a feeder service calculated with NEC. We'll be looking at that. Reading on down the next paragraph, when transformers are not involved, a relatively simple calculation involving only one voltage results. If a step-down transformer, that's what we was talking about earlier, we see those on jobs, we go from 480, 277 to 12208, that's common. That's what you see on your jobs. If a step-down transformer is used, the transformer itself must be protected by an overcurrent device. I'd underline it. If a step-down transformer is used, the transformer itself must be protected by an overcurrent device that may also protect the circuit conductors in most cases. Okay. In other words, it might have to have a disconnect, right? Or a circuit breaker. Switches and panel boards used for the distribution of electricity within a commercial building are also subject to NEC rules. The risk requirements could affect the number of feeders required. And we would see Article 408, which we may get. Let's just look at Article 408 and see what it says. No, 408 is the title of it is panel boards. Okay, so we may have to go there later, but it's just 408 is just dealing with panel boards, switch boards, switch gear, and panel boards. Kind of the rules for that. That may be something we apply. All right, 3.1.0, commercial and industrial lighting loads. So we're going to do lighting. First thing, lighting. We were just talking about that. Type of occupancy determines the method employed to calculate loads. Industrial and commercial buildings, 2 of these categories. Standard calculations used to compute the load and determine the service equipment. Requirements are arranged differently from those on dwelling. There are specific types of loads that must be considered. Let's kind of look at some of this. Let's look at 215.2. .2 is talking about minimum rating and size for a feeder. See that there? Okay. Minimum rating and size for a feeder. Section 220.42, go there now, 220.42. Actually talks about general lighting. 220.43 talks about show windows. 220.44 talks about receptacle loads other than the dwelling units. And it tells you what to refer to as far as how to calculate that. Sometimes the code book refers us to a different section we have to go back to. Like, this is a good example. 220.44 says receptacle loads calculated in accordance with, and you have to go back to 220.14 H and I to see what it says. Shall be permitted to be made subject to the demand factors given in. Now, there's another demand factor table there, 220.42. You see that there? See, the table 220.42 is the lighting demand factor, and that's what we were doing earlier. The first, for like a dwell, we're like, let's just take like a store. What would a store be on? If we were doing a retail store, what would retail store fall in table 220.42? Which category?
All others?
All others. Exactly. How about a school?
All others?
All others, yeah. So that's that table. Now 220.44 says demand factors for dwelling receptacle loads. And you kind of see what it allows you to do there. That's just for receptacle loads on a dwelling. That's the only time you use that table. Okay. All right, if we look at 220.50, right there on the same page, you see that motor loads shall be calculated in accordance to 430.24, 25, 26, and 440.6, etc. That's where you're going to calculate those from. 220.51 talks about heating, fixed electric space heating. And you see that it shall be calculated at 100%. See that there? 220.51.
Yeah.
220.56 actually talks about kitchen equipment. And you see there, the more units you got, you have a demand factor that may apply. Like if you had 4 units, your demand factor would be 80%. Yeah. 220.60, non-coincident loads, where it is unlikely that 2 or more non-coincident loads will be used simultaneously and shall be permissible to use only the largest. Okay? Like HVAC, right? You're only going to use heating or air. You're not going to run them both at the same time. And because of that, when you're doing calculations on heating and air, you just use the largest one. Determining what that is. And lastly, the 220.61, there are cases where we can actually reduce the neutral size. And that's covered in 220.61. Reading on, each load must be designated as either continuous or non-continuous. Continuous is going to be a multiplier of how much percent? How much is a continuous load? What I just write down up here a minute ago.
For general life?
Now, how much percentage is a continuous load? What's your multiplier going to be for a continuous load?
180.
125%. I'd write that down somewhere. Continuous load, 125%. Okay? You got something to write with? Okay. Continuous load, 125%. Most commercial loads are considered to be continuous. I think that's important. One exception would be a storage warehouse that's just occupied infrequently. Demand factors may be applied to various non-continuous loads. For example, 220.44 permits both the general purpose receptacles and the fixed outlets to be adjusted with for that table that we were talking about, those 2 tables we was talking about earlier. All right, lighting loads, 3.1.1. Lighting loads are divided into 7 different categories. We looked there. 220.12. It's just general lighting. And we see that on our table. 220.12 It lists it says, branch circuit load, 220.12 load for specific occupancies, and if you go on down, we're just talking about general lighting. By occupancy, whatever it happens to be, and we see that there on our table, don't we? There, we vary, our load on our lighting depends on what type, what's actually in the space. Like, you don't need as much lighting for a warehouse as you would a school, right? Makes sense, doesn't it? The next bullet point it says there is 220.14D. 220.14D, it says luminaire. It says an outlet supplying a luminaire shall be calculated based on the maximum volt amps of the equipment and lamps for instance. In other words, we look at whatever the wattage of the lamp was to determine that load. 220.14F, we done went over that. That's talking about signs. How much is a sign? How many volt amps is a sign?
$1,200.
1200, yeah. How many volt amps is just a regular receptacle?
180.
180. How many volt amps is a show window per foot? $220.14G.
200.
200. Okay. All right. 220.18B. This talks about inductive and LED lighting loads. You can see what it says there about that. 220.43B is one we haven't covered yet. And on B, talks about track lighting. Track lighting, you probably don't have that like in a jewelry store. You'd have a bunch of it, wouldn't you?
Yeah.
So it says for track lighting and other than dwelling, an additional load of 150 volt amps shall be included for every 2 foot track. So 120, is that what it said? So if we had a 5 foot piece of track, how many volt amps would that be? So it's 120 what?
Per 2 foot.
Every 2 foot. So you got 120 here, 120 there, that's 2 foot, 2 foot, and this is 1 foot. How many is this 1 foot gonna be?
60.
Nope. How much is that 1 foot gonna be?
120.
Thank you, 120. But it says for anything over, you've got to go ahead and count it as a whole. So that becomes 360. And so, an 8 foot would be what? 120, 120, 120, 120, right?
Yeah.
So that would be what, 480
Yes, sir.
volt amps? How about a 7 foot? A 7 foot would be the same as an 8 foot, right?
Yes, sir.
Okay. A 6 foot would be the same as a 5 foot. Agree?
Uh-huh.
Okay. So that's track. And most of the time, track, you can cut it, but the standard lengths are 4 foot and 8 foot. That's how the lengths come as far as when you buy them. And you make the couplers, but yeah, you could have a 5 foot piece of track. You can have a 7 foot piece of track. You can take that 8 foot, cut a foot off of it, make it a 7. Or you can take that 4 foot, 2 4 foots, cut a foot off of it, make it a 7. I don't know what you got. But they are joinable with a coupling. Okay. But that's track lighting. We see that there on B, 220, 43B. Okay. And that's other than dwelling now. So it'd be like in a store. All right, 3.1.2 general lighting loads. General lighting load is the main lighting used. It's like what we got here. This is a general lighting load. Okay. Within the building, in additional lighting installed for accent, display, show windows, signs, all that's general lighting load. It is computed based on the type of occupancy. We know that. That's what we've been looking at the 220.12.
Yes.
For type of occupancies not listed in 220.12, the general lighting load should be calculated according to the NEC listed previously. That's probably important to remember. We read on over the second paragraph. It says any of these loads that are continuous are multiplied by what?
125.
25, to determine the overcurrent protection device and the conductor size. Understand that. So, to determine both the overcurrent device, which is what?
Overcurrent device?
Hmm? What is the overcurrent device? Circuit breaker? Is a circuit breaker an overcurrent device?
Yes.
Yeah. Okay. And the conductor size, so whatever size wire we're going to use. All others are calculated at 100%. Non-continuous loads may have a demand factor applied in accordance with 22042 and table 22042. So let's look at this example. Suppose we got a warehouse, 57,600 square foot. Okay? Let's go to our table and let's find warehouse and tell me what we're going to do.
First 1250 is 100.
No, we ain't gonna do that yet. We gotta go to 220.12 and find out what our lighting load or lighting load demand is first, based on a warehouse. We've got 57,600 square foot, and for a warehouse in that table, what is their lighting load multiplier?
0.20.
Huh?
0.25.
0.25. So do the multiplication on that and tell me what you get.
14,400.
Yep, 14,400. Okay, so we got that. Now we do the next step that you wanted to do. Okay, let's look at 22042, which was where you were at a minute ago, and it says what? Table 22042. Now we have to go to warehouses. It says apply the first what?
12,500.
500 at what?
100%.
100%. So we're just going to pull this 12,500 out, aren't we?
Yeah.
Now we're going to have, what we're going to do to this 12,500?
Subtract from 14,400.
Yeah. 9, and that's what, 1,900? Is that right? Now we're going to do that 1,900.
Times it by 0.5.
Yeah. Times 0.5, which is what? 800? No. That's not right. How much is it? 950?
950.
Yeah. Now what we're gonna take this 950 and do with it? What we have stuck over here, we already taken out.
12,500.
Yeah. What we're gonna do with the 950? Add it to it. And that gives us a total then load of 13,450. Make sense? Take a look at it, make sure you understand. We had 100% of the 12.5. Well, first of all, we took 25%, got where we need to go. We took 100%, we pulled it out, put it over here. And we took the rest of it and we got 50% of it, and then we added it back into the 12.5. See that there, Cameron? Got it?
Yes, sir.
Okay. All right, show window lighting, 3.14, we got an example here. It says show window requires that the lighting load be calculated at 200 VA per foot. So we got a 55-foot show window. 55 foot. What are we gonna do?
Times it by 200.
Yeah. And we're gonna get how much?
11,000.
Okay. Volt amps?
Yes, sir.
What does volt amps also stand for?
Watts.
Watts. Okay. All right. And volt amps is really, that's volts times amps, right?
Yes, sir.
What does volts times amps equal? volts times amps equals what?
Power.
Equals watts, right?
Uh-huh.
That's why it's the same thing. Volts times amps equals watts. Okay. If you had 120 volts, you got 5 amps, you're gonna have what? 600 watts. Okay. Reading this as volt amps is watts. And that's literally volts times amps is what VA stands for. All right. Show windows, the next one, track lighting. Track lighting is allowing 150 VA for every 2 foot. So it says we got 140 foot of track. So what are we gonna do? 140 foot? What are we gonna do? So every 2 foot, we just gotta find out what? We need to divide this by 2, don't we?
Yes, sir.
So now we got 70 foot that we're doing times what? Every,
150
Yeah.
volt amps.
so we're gonna do 150 times 70, right? And how much is that?
105.
How much?
105.
150 times 70 is how much?
I did it wrong. I did 145. 2,500
Yeah. And that's what? 2,500 what?
volt amps.
Volt amps. How much did you say? You need to look at your calculator. Let's do that. That don't look right. 70 times 150. I got 10,500. Is that what you said?
Yes, sir.
Oh, I thought you said 2,500. Okay, I agree with you with 10. I just misunderstood you. All right. Okay. Page 30. You good on that?
Yes, sir.
Example number 2 said if you got 21 foot of track, what would you do? You take 21, you divide it by 2, it gives you what? 21 divided by 2 is what?
10.5.
10.5. But really, because it's 10.5, what is their multiplier going to be? 10 or 11?
11.
11. And we do 11 times what? 150? Is that right?
Yeah.
How much?
$1,650
Yeah. 1,615 volts,
volt amps.
volt amps. Okay. Looking at a little green note there. Any loads that are continuous are multiplied by 125%. We've been talking about that. All others is 100. Next section, outside lighting loads. Outside lighting loads are calculated by multiplying the rating in VA by the number of fixtures. So that's pretty easy, 220.14D. Example, we got 30 outside lighting fixtures. They're each rated 250 volt amps, which also stands for what? Watts, right? Including the ballast, these lights are rated 240 volts. So really, all we got to do here then is we got 30 fixtures. It tells us to do what? Take the 30 fixtures and multiply it times the volt amps, which is, we already have, was 250, right?
Yes.
The 30 times 250 is what?
$7,500.
Yeah, 7,500. I'm gonna see if I can find a little bit better marker. Do this a little better. Yeah, it's a little better. All righty. Sign and outline, 3.1.6. We said earlier that a sign is how much?
200, 1,200.
1,200 VA. Okay, 1,200 VA. All right, so let's take a look at this long one here. Load for a retail. So let's do a load for a retail store, and then we'll take a break. Let's look at this one. Load for a retail store, and we'll take a little break. Let's take it all. So a retail store. Let's think about what all we got. Let's look at step one. Tell us what to do. Well, let's see what it says it has in it. It tells me I got a small store. I got show window in the front, which is typical, right?
Yeah.
Storage area has 4 general purpose duplex receptacles, while the retail area has 14. 2 floor mounted receptacles for a total of 16. These combined with the storage area and receptacles bring a total to 20 outlets that do not supply continuous load. What are the conductor sizes for the service if the 120/240 single phase will be used? First of all, we got to do we got to figure out how many square foot it is. Okay. We got to figure out how many square foot it is. Total number. If we look, and we're looking at the building. We're looking on page 31. How do we determine the square foot for this space? By looking at the floor plan on page 31. How do you determine the square foot?
Oh.
How do you determine the square foot of this room? You got to take what?
Length and width.
All right, now look at that drawing. Tell me what the length and the width of that space is on page 31.
38.
No. You look at the same drawing I am?
Yeah, 31.
Yeah, on page 31. That drawing, how wide is that building?
50.
50, thank you. What's the length?
80.
So our square foot then would be how much? $50 times 80. You need a calculator?
No, I don't.
You want one? How much?
50 times 80.
Yeah,
4,000.
4,000. Okay. So now we got to get the lighting load based on that. So we go back to table 220.12, and we see that for a retail store, how many volt amps per square foot are we going to do for lighting?
Orient the lighting
Mm-hmm.
for retail store.
Yep. Table 220.12. For a store,
No stores.
a store.
Okay. Number 3.
3. So we're going to take 3, multiply it times what?
4,000.
All right, we're going to get 12,000. That's our lighting. That's our lighting. So we're kind of write that down and put it to the side. That's our lighting for this store. Okay. All right. It tells how many. If we added all those outlets that we had what, 4 in the back, right? 4 outlets in the back. You agree?
Mm-hmm.
We've got 14 up front is what it says. So that's 18. You with me? We had 2 floor receptacles. So that's how many outlets? Four plus 14 plus 2. 20. So we got 20 outlets. This is lights. We got 20 outlets. And an outlet is how many volt amps each? 180. So we're gonna multiply 20 times 180 and we're gonna get how much? $3,600? Is that right?
Yes.
Okay. Now look in your book. It says step 4, we've got show window. We got how much show window? By looking at our drawing, how much show window do we have?
30 feet.
We're going 30 foot of show window. So this is receps. Show window, we got 30 foot. How much we gonna multiply that times? 200?
200.
That's gonna give us what, 6,000?
Yes, sir.
That's show window. All right, right now that's what I got written down. 12,000 for lights, 3,600 for receptacles, 6,000 for show windows. Let's see what else other kind of load that we have. All right, sign. It says there's a sign. You see that there on the drawing? It says sign, doesn't it? Sign outlet. Look at step 5. It says allow 120 amp outlet for sign or outline if store is on the ground floor. If the actual load of the sign is not known, then we're going to do 1,200, right? We don't know the sign. It doesn't tell us. It just says that it got a sign outlet. So our sign is going to be, we automatically know by the code, is 1,200 VA. Right? Okay. All right. Which loads are continuous and which ones are non-continuous? How about a sign? Would the sign be continuous? Sign. How about a show window? Would it be continuous?
Yes.
How about lights inside of that store?
No.
Yeah, I think they would. Don't you think that lights on that store gonna be on all day?
Inside?
Yeah. You come in the store on 9 o'clock in the morning, you ain't gonna cut the lights off till you leave, right?
Yeah.
It'd be continuous, wouldn't it? 12,000. How about receptacles? Not necessarily, would they? So these are continuous loads. So let's add those up. See how much we get. You agree with 19.2? You agree with me yet?
Not yet. Okay.
You with me? Continuous load, what do we have to do with a continuous load? We have to multiply it by how much?
125.
Thank you. 1.25. And how much does that equal? 19,000 times 1.25. You need to get you a better calculator. You need to buy you a little calculator. Trust me, a little calculator. 19,000 times 1.25 is how much?
19,000.
19,200 times 1.25.
Uh, 24,000.
24,000?
Yes, sir.
Okay, I agree. Now, what do we still have left? What have we not done anything with?
The receptacle on it,
Exactly. So what do we have to do then?
add all these in.
We'd already done it. We already down to here, so we're just gonna add 24,000 to what? 3,600?
Yes.
27,600. That's our total vote ounce for that building. Or what? Do you agree with me?
Yes, sir.
It told me my service was what? Single phase or three phase? In the description. What did it say?
Single,
Single phase, what's the voltage?
the volt at 122.40.
So we're gonna divide, to get to amps, we're gonna divide this watts by how much?
240.
240. Let's see what that gets us. Hopefully about 115.
$115.
Yeah, very good. There you go. That's your, but now let's do one thing. Let's don't stop there. Let's go to 240.6. And just look at something. 240.6. And we see that common standard ratings for overcurrent devices are fuses. And so we've got 115. What would be the standard size fuse or circuit breaker that we'd have to use for this circuit, for this?
Wouldn't that be
240.6.
240?
Standard size fuse or circuit breaker. If we got 115, what would our circuit breaker size need to be?
I'm at 220,
240.6.
240.
Should be a list of standard fuses. You got a 2014 code book? Huh?
Yes.
Page 96,
96.
down to bottom. And the top page 97. Standard size fuses or overcurrent device.
It will be 125.
125. I would highlight that table right there, circle it some. You got a highlighter? Apparently not. I ain't got one. Just circle it. You need to know that. You use that table right there a lot. Okay, circle that. All right, I got a red pen here, be right to use it. All right, let's take about a 5-minute break. But the next one we want to do is as a load calculation for an office building. And it's pretty long. You can see there it's about 11 steps. We got an office building. And you look here on your book, we got a good bit going on here. First thing, I want you to notice the voltage. And I want you to notice that it's three-phase. That's very important, remember, for later, that it's three-phase. What's the square root of 3?
1.5.
1.732. Matter of fact, if you do that on your calculator, you could actually, there's actually a button on your calculator to tell you that. See it?
1.73.
Yeah, 732. All right, so we got an office building, 20,000 square foot. You got a 480, 277 three-phase service, and it contains the following. You got 10,000 VA sign, three-phase sign, 100 duplex receptacles, supplying continuous loads, 30-foot of show window, a 12 kW or KVA range, a 10 kVA oven, a 20 kVA water heater, 75 incandescent outdoor light fixtures. I'm just reading it there. You see it there where I'm reading?
Yes, sir.
200 VA, 200 fluorescent, so fluorescent light like we got here. 7.5 horsepower, three-phase motor, 40 kVA, three-phase electric heating unit, and a 60 amp three-phase air conditioning unit. Got all that in that office building. Pretty typical. Okay. All right. If you look at the single line over there on page 33, we see that. We see the incoming power, 480. We see the main distribution panel. And we're putting the loads that are 480 in this main distribution panel. You've got a water heater, which we listed there, a heater, the motor, 7.5 horsepower. We're going to have a transformer that's going to feed our 208 volt loads. We're going to have the HVAC, which is, we see there, and the lighting panel. Okay. And then in our 208 volt lighting panel, we're going to see what we got. We got a sign, we got a range, we got an oven, receptacle load, outside lighting, and show window. All that's in our 208. Understand that?
Yes.
Right. Step 1 tells us in step 1, it tells us to calculate the load for the 100 receptacles. Okay? So, calculate the load for the 100 receptacles. Let's just do that. 100 receptacles. So let's put this here. Recept. 100 times what?
180.
Okay, it's going to equal how much?
18,000.
18,000. All right, that's step 1. All right, see that in your book, step 1. Step 2, apply the demand factors from NEC 240.44. Okay? Or 240.44, we go to our code book there, 240.44. What'd I say? 220.44, my bad. Yeah, that didn't look right. 220.44. That table says the first 10,000 is how much?
100%.
100%. And then what? Then what does it say? The remainder is 50%, isn't it?
Yes.
So we're going to take 8,000, which is what's left, times 50%, aren't we?
Yes, sir.
Which equals to 4,000. So really, our receptacle load then changes from 18 to what?
To 14.
14. But we'll just kind of mark through that for now. Okay? So that's our receptacle load, okay, based on that table right there. Step number 3, calculate the, we got a show window. We know how much, so we got a show window. How many feet?
30.
Times how much?
200 V8.
Is how much?
6,000.
All right. We're going to put that there. Leave that there for now. All right. So right now we're doing the 208 volt stuff. That's what we're doing. All right. Incandescent lighting is part of that. Incandescent lighting, they told us they had 75, and they were how much each?
120,
How much?
150 watts.
150 watts. And we had 75 of them, is that right?
Yes, sir.
How much does that give us?
$11,250.
Okay. All right. That's that step there. I put that up there. And if I was doing it, if I was to you, I'd be writing this down, all right? You know, if I was doing this, that's what I'd be doing, writing it down, just like I got it, all right? Next step, we're still in the 208 volt panel. We have a sign. It told us how many VA it was. What did it say about the sign? 10,000 VA, didn't it?
Yes.
Okay. 10,000 VA sign. We're going to multiply that times what?
It says 1,000.
But I disagree with that, don't you? I thought it'd be what? 1,200, wouldn't you?
Yes.
Oh, I know what it is. They're giving you, okay, here's what we got. Okay. They said it's 10 kVA, is what it says, okay?
Yeah.
So they're actually giving us the size. We're not determining the size of the sign. They've already given it to us.
Okay.
And so to get to, all these are what? VA, right?
Yes.
VA, VA, VA. This is KVA. So to get to that, what do we have to do? Multiply this times what?
1,000.
Times 1,000. So we got sign would be how much? 10 times 1,000 is 10,000, right?
Yes.
And that's VA. They actually give us the sign. It's not an assumption. Now the oven, they give us that too. What does it say the oven is? 10 kVA, three-phase oven, don't we? So we're going to do the same thing, aren't we? Oven, it's going to be how much?
10,000 VA.
10,000 VA. Okay. All right. So we're down to step number 6, which is talking about the range, which is under the 12208. And they tell us the range is how much? 12 kVA? Is that what they said?
Yes, sir.
So our range then is going to be how many VA?
12,000.
12,000. So we're just changing it all into the same thing. Okay? 208 so far. Everything we got 208. All right. So step number 8, we're breaking out the continuous and non-continuous. It tells us, and I agree, the non-continuous would be a range. It's probably not going to be put on for 3 hours, is it? What's the other one that told us it was non-continuous? An oven?
Yes.
Didn't it tell us that? That the only two they list is non-continuous? Yeah. So our non-continuous load is 22,000. That's non-continuous. Just don't put NC. So that means the rest of our load, I think our receptacles, because they actually said our receptacles were what?
Continue.
Continuous. Showing, is it going to be continuous? Yeah, right? Incandescent lights and the signs. We're going to light all those up then. So that's 20, 30, that 41,750. That's at 2. 41,250, right? Okay. 41,250, that's our continuous load. Go ahead and do it, and then, so we can be on the same page. All right. Continuous load, what we have to do anything that is non-continuous load? No. But we have to do something to continuous load.
125.
How much that equals?
Uh, 51,563.
Yep. So that's their continuous load. That's our non-continuous load, 22, 51. So what are we gonna do with those two numbers? We're gonna add them together, aren't we?
Yes.
We're gonna get 73, 563. Is that right?
Yes.
Okay. So what's their 208? This is watts. This is watts, or VA. That's our total load right now for 208.
Yes.
But we said it's 208, three phase. So normally, if it was single phase, we'd take 73 VA or watts and we divide it by the voltage, wouldn't we? Which would be 208, right?
Yes.
But because it's three phase, we got to do what? We got to multiply that times 1.732, which should give us like 360, close to it. See if you agree with me.
1.732. I got 484.96.
208 times 1.732
1.732.
times 208 is how much?
480.96.
You ain't doing something right. You need to get a different calculator. I'm gonna do it on mine. 208 times 1.732 is equal to 360.256.
Oh, okay. I know what, I got I put
Okay.
280.
So now we want to divide 360 into 73,563 and see how many amps you get. About 204. Close to it.
Yes.
Okay. So our 208, we're gonna erase all this now, I don't think we need it anymore. Except we're gonna remember one thing. Our 208 is what, 204 amps?
Yes.
We may need that. But that's our 208. Now we gotta look at step number 10, and it refers us to 480. We're talking about getting to there. Well, it talks about the wire. So we're gonna go to 310-15B16, we go ahead and size this wire for this 208. Okay. Well, first of all, we'd have to go and find out what size breaker we'd use. We're gonna go to what, 240.6? We'll find out what kind of overcurrent protection we're gonna use. For that 204 amps, it would be what?
225.
225, very good. Now let's go to 310-15B16 and find out what size of copper wire we're going to use. We got to base it on the overcurrent device. Copper wire, 75-degree column. We would use what size wire?
4
4 very good. All right. So that's what we've done, step number 10 there. See there, step number 10.
Yeah.
Okay? All right. But the transformer, there's a transformer that feeds all this. So look at step 11. Look at step 11 in your book. The transformer is sized to accommodate the computed load of 73,563, which is what we come up with. Select the overcurrent device for the transformer. Okay? All right? The way to do that, we've got that. We already got that. How much was it? 73,563? right?
Yes, sir.
Now we're gonna divide that same number. A few minutes ago, we did 208, but now we're gonna do 480 times 1.732. Now this also three-phase. See how much that comes to? $480 times 1.732.
831.36.
831. Now we're going to divide that into 73,563 and see what we come up with.
$88.58.
Very good. That's what's feeding the transformer. That's what feeds that transformer. So we look there, okay? Step 11 says NEC 430.3, because the secondary protective device is used, the maximum setting of the transformer, okay, overcurrent device shall be 250%. So we're going to take that 88.5, we're going to multiply it times 2.5. 88.5 times 2.5.
$221.
Yeah. If you look there in the book, that's what it come up with. It says, let's just read this, understand this together. Okay?
Yeah.
All right, so it says, let's go to 430, 3B. $450, I'm sorry. $450, because this talks about transformers. $453B, overcurrent protection, and you see there what it listed there. You see there if it was saying maximum for the overcurrent 2.5. We see there we're primary protection, we're 1,000 volts or less, and we see maximum rate overcurrent by transformer 1,000 volt percentage based on secondary protection, primary protection. I'm on page 362 there at the top.
Yes, sir.
Primary and secondary protection, we see 250%. Okay. That's where we get that number from. So if you look what we did, and we see there in our book, it says 221 amps. That is, it may not exceed this rating. The secondary protected device is 125%. We get that from that same table. Okay. So we go back to what we had earlier, because we had that 204 amps. And you see the maximum you could actually do that would be 1.25, would actually, it's 255, okay? For that table, that's the maximum. So that would be the largest permissible standard overcurrent device then would be 250 amps, okay? So that's, but we're back to where we was at a minute ago. Let's don't worry about that, all right? But I'm just kind of showing you that. Now we got to do the primary, the 480. And if we do this, we're going to call it a night. Okay, we're done. So look at the primary feeder, which is a 480 we were trying to figure out. Now for feeder calculator, let's start with the lighting load. So we're back to our example here. Okay, we see that it said what, 20,000 square foot? Okay. 20,000 square foot, so we got to go back, we got to find what kind of multiplier we're going to use for this. So we got to go to 220.12, and we're going to find out an office building is how much? 220.12, we're gonna find in an office building,
Three and a half.
times 3.5. And we're gonna multiply that out and see that it's 70,000. All right, that's our first step, which is shown there. Okay? But the actual, now let's look, that was if we did 3.5, but if we look here, the actual is shown as what? It said there was 200 light fixtures at 200 VA each, wasn't it? You see that in there? It was 200 of them at 200 VA.
Yes,
So that's 40,000. So which one is larger?
the 70.
This one here is larger. So if you see there in the book what it says to do, it says since the connected load is less than the NEC, it is neglected. So we have to use the 70,000. Okay? Now we get to the lighting load. So we got 70,000. And it's 480. Multiply that out and see how much that comes to.
$84.2.
84.2. Lighting load is a continuous load.
So it's 125.
You getting it? So now how much is that going to equal?
105.2.
Yeah, 105.25. That's shown there in their book. Okay? So, and then it says the next rated would be 110. We find out with 240.6. So we'd go to 110 on our lighting. You agree? Yeah,
Yes.
trust me. Okay. All right. Now look at the next part. Okay. Feeder supplying the water heater. The water heater, it said it was what? It just said it was 20 kVA, didn't it?
Yes. 20,
And so 20 kVA is how much?
20,000.
Yeah, 20,000. Okay? So we just want to leave that at there for now. It says 220.51 says permit the feeders on the electric space heating to be 100%. We had some space heating. So 40 kVA space heating is how much?
40,000.
40,000. Okay? 40,000, which is what it shows in the book. Okay? Now look at the next part. Requires that motor loads be computed. Full load amps. Okay? We'd go to our table, we'd find that we would see that the full load amps taken from table 430, 250 for a 3-phase motor, 7.5. Let's see what that is. $430,250.
For a 7.5,
Yeah,
for 200 volts,
480 volts.
480 volts. So that's 460.
Yeah,
11.
11 amps. Okay. All right, 11 amps. Now we got 11 amps. It's 480. Okay. To get to volt amps, this is amps, right?
Yes.
So we got, but to get, so this is our amps. To get to volt amps, we got to multiply it times volts. But our volts is actually 480 times 1.732, right?
Yes.
Of this 3-phase. So we're going to do 11 amps times 480 times 1.732. And because it's a motor, it's continuous duty, so you can do it all at one time if you want to. You can do 11 times 480 times 1.732 times 1.25 and see how much you come up with. I'll do it with you. We got 11 times 480 times 1.732 times 1.25 should equal about 11,431. See if you agree. You agree with me?
Yes.
Okay. All right. We see there that we have one thing left here. Okay. We got the 60 amp air conditioning unit. Okay. So 60 amps, so to get to volt amps, if we already have amps, what do we have to do? Multiply it times volts, right? And it's 483 phase, so we're going to 60 amps times 480 times 1.732. You with me?
Yes.
Okay. Let's see what we got there.
49.
49,883.
Yes.
Okay. All right. So, look at our, we're just going to look at our example down there, table 1, main service guide. So what we're doing, we're taking all this load here and we're putting it into this table down here at the bottom. If you look there, we had 88.5 amps, 12208. We've seen what our lighting was at 105. Our water heater was 24 amps.
Yes.
Our electric heater would be negated because the air conditioning load would be larger, remember? It's either or. Okay. We had the motor, which was 11 amps. We had the air conditioner, which was 60 amps.
Yes.
And we take 25% of the largest motor, which we just had one, and we see that the service comes to 291.5 amps. That's it. That's all we have to do. What I want you to do for homework, I want you to absorb that right there. There's a lot to absorb, especially. But I want you to read, start reading right there, 3.2, and you're going to read through just 2 more pages. You're just going to read to the bottom of page 37. So we're start right there. We're going for next week. We'll go all the way down to you'll stop at 3.7.0. See that there?
Yes. And I'm reading from 3.3.2.
3.3.2 through 3.6.0, really. You're reading through the end of that.
Okay.
That brings you up to 3.7.0. Did I give you a handout for section? Let's see.
Yes, I got section 2, 1, and 3.
You have 3. You should be working on section 3
Yes.
and have it ready for us to discuss next week. You should be done with that.
I only got 3 missing.
Okay. So I'm kind of looking here. Complete handout. Be ready to discuss next week. Read sections, what I just told you there, through 3.6.0. Then we'll be ready to discuss that for next week. Okay. We good?
Yes, sir.
Okay. All right. We'll wrap it up. Okay. You can have it. Here, just keep it.